testing using a one sample t-test. Now, imagine that we had this data where we had the weight of various babies that were born in our hospital. And we looked at our data, our sample of data, and we wanted to test to find, is the average weight of infants born in our hospital less than 3,100 grams? Well, what I need to do is a full 7-step hypothesis testing procedure. And in this case, what I do is I start with the alternative hypothesis. I start with what your book calls step 2. So in this case, what I'm asking is if the mean is less than 3,100 grams. So that's what I write down. And then I move on to step 1 after doing step 2. For step 1, I do the HO, the null hypothesis. In this case, it's got to cover all the bases, every possibility other than what I've already covered in step 2. So if our mean is not less than 3,100 grams, then it must be either greater than 3,100 grams or it must be equal to 3,100 grams. So our null hypothesis states every possibility except for those covered by our step 2, which is our alternative or our research hypothesis. So now I'll move on to step 3. Step 3, we just state what our alpha is. Now we typically use an alpha level of 0.05, and that's what we'll use here. In this course, use 0.05 unless specifically told to use some other alpha level, which in rare case might be 0.01. And there is some times where people use 0.10, but only when finding significant effect works against their doing something. Well, almost that's the only case. So here we're going to use an alpha of 0.05, which is pretty typical. Step number 4, we need to find the rejection region. Now before we find the rejection region, let's look at our situation here. What we're asking is if the mean of the data is less than 3,100 grams. So I'll draw a normal curve. We have to assume a normal curve in this case. We put the mean of, we've got an alpha of 0.05. And now normally what we do is we do a two-tail test. And normally what we want to do is we take half of the alpha and we put it on each side of the curve. So we put half in the left tail and half in the right tail. But in this case, we want to do a one-tail test. So in this case, we're only going to reject if we get a t-score less than some negative t, because we've got 3,100 grams, and what we're trying to do is demonstrate or find if our infants are significantly less than 3,100. So that would be on the lower side or in the lower tail. So we need to put an entire 0.05 in the lower tail. Now whenever you do, whenever you're trying to find the rejection region, and you're doing a t-test, you first need to find degrees of freedom. And the degrees of freedom is the number of scores minus the number of groups. Now this, by the way, degrees of freedom are calculated differently for different types of statistical tests. So you can't learn one rule for degrees of freedom and apply it to everything. In this case, for t-test, it's the number of scores minus the number of groups. In our case, we only have one group of infants. And if I count right, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 scores. So we have 10 scores minus, because we have one group, that gives us 9 degrees of freedom. So our degrees of freedom are 9. Now one other thing that I need to explain before we can have Excel calculate this for us is Excel assumes that we're using a two-tailed test. So it's going to take our alpha and divide it into 2 and put half in each tail. So if we want to put our entire alpha in one tail, what we really have to do is kind of trick Excel. What we need to do is double what we tell Excel our alpha is, so when it cuts it in half, it'll put the entire alpha in each of the 2 tails, and then we'll just look at one of those tails. So in our case, our alpha is 0.05. So we're going to tell Excel that our alpha is 0.10, which is twice 0.05. And then it's going to divide it in half and put 0.05 in each tail, which is what we want. We want 0.05. And then it'll give us a t-test, and we'll know it needs to be negative. And we'll make it negative and put it on the left side. So how do we do that? Well, the first thing I'm going to do is I'm going to go down to cell A13. I just picked an cell. And I'll put T crit, meaning this is where my T critical value will be. Now I'll go over to B13, and I'll type in an equal sign, then TINV, stands for T invert. Normally, when you're doing your T, you give it values and you try and find out what its probability is. This is the inverse of this. We're going to give it a probability to find out what the T score is. So in this case, I put equal sign, TINV, then left parenthesis, and now I don't tell it where the data are. Instead, I first tell it the alpha probability, which we're going to trick it, say it's 0.1, and then I put a comma, and then I have to tell it the degrees of freedom. In this case, we have 9 degrees of freedom. Then I'll close the parenthesis, and then when I hit enter, I will get 1.833114. So this is what I'll put in my rejection rule. So here's the picture where I've added in the value that we got from Excel. So now I know that if I'm going to get a T score which is less than negative 1.8331, I can reject the HO. But if I get a T score that's greater than a negative 1.8331, I'm going to have to fail to reject the HO. So let's put this in our rule. Here we are. Here's our rule. I'll say reject HO if the T comp is less than negative 1.8331. So now what's left to do is to calculate our T comp by using our data and using Excel. So to get our T comp, what we do is we go up to Tools, we go to Data Analysis, which is at the bottom of our menu usually. We click on that. We click on Descriptive Statistics, so I'll click on Descriptive Statistics. I'll click OK. For the input range, I will click from A1 to A11, and I will then say columns. I'll click on labels in first row because it says weight there, and that's a label. For the output range, I will again put, click in this box first, make sure you do that, then put C2. We need to click near Summary Statistics. We don't need the confidence level, so I'll leave that unclicked. And I'll go ahead and click OK. Then what I'll do is I'll click Format, Column, AutoFit Selection. Now this has pretty much what I need to do to get my T-comp. But Excel doesn't do a single group T-comp automatically. I'll need to do that more manually. But I've got all the information I need to do in here. So I'm going to go down here to C17 and click, and there I'll put T-comp, C-O-M-P, just as a label to tell me what I'm going to calculate. I put that in C17. Now I'm going to move over to D17, and here what I'll do is I'll calculate my T-comp. Now a T-comp, because I'm going to do calculating, I'll press equal sign, and now all I do is I press my left parenthesis, and the formula for the T-comp is that I take my sample mean minus my hypothesized mean, and then divide that whole thing by the standard error. So in this case, I'm going to take my mean, so I'll just click on the 46.4, and then I'm going to subtract from that my hypothesized mean, which was a 3,100 grams. I'll close my parenthesis so that it'll do the subtraction first. Then I'll press my division button, which is just a slash, and then I'll click on my standard error, and it'll be put in there in my formula, and then all I have to do, and by the way, it doesn't matter if this equation goes outside of the cell. It didn't in my case, it might in your case, but it really doesn't matter, because once I hit enter, it's going to just become a number anyway. So now I'll just press enter, and what we get is negative 2.2678. So I'll take my T-comp, and there's one other thing. I'll take my T-comp and put it in with my other steps. But before I do that, before we leave here, I want to do one other thing. I want to find something we'll need for step 7, which is called the p-value. So I'll go down here to C18, and I'll type p-value. So I put p-value. And now I'll go over to D18, and there what I click is so I've clicked in cell D18, and here I type an equal sign, then I put TDIST, stands for T distribution, then I'll put in left parenthesis. Now this time it says to put in my X value, which is my T-comp value, but Excel won't do negative T-scores, so I'm going to put in a positive one, so I'm going to have to type it in, because if I clicked on it and it's a negative, it won't work. So I'll put in 2.2678. That's, well, the more I put in, the better. 40967. And then I put a comma, and I have to tell it the degrees of freedom, which were 9. And then I put a comma, and a comma, and then I need to tell it whether it's a one-tailed or two-tailed. We're doing a one-tailed test, so I put a 1. I close my parenthesis, and now I hit enter. And this tells me the probability of getting a t-score this low if the real mean is 3,100 grams. The probability I get a sample that by coincidence just has a mean this low is only 0.0248. So that's pretty low probability. So now I'll take these numbers and put them in my 7. So here we've added our T-comp to as our 5th step. So our T-comp, we know from Excel, is negative 2.2678. Now let's take a look at what we did for step number 4 again. Let's review that. We said we were going to reject HO if the T-comp was less than negative 1.8331. And our T-comp is negative 2.2678, which is less than negative 1.8331. So we are going to reject HO, and that's step number 6, is rewrite reject HO. Now the last step is step number 7, and it's probably the most complicated of the steps intellectually. Now we don't even need to use Excel, but conceptually step 7 is where we put all of what we've done in the first 6 steps together. Step 7 actually has, which is the conclusion, actually has 3 different parts to it. The first part, whether or not we've rejected whether or not we decided to reject HO or not. Whether or not we've done that, we always start with this part for our conclusion. We always say at an alpha level of blank. And here we put in our alpha level, which in our case was 0.05 and usually will be 0.05, but in rare cases maybe 0.01. The second part, it changes depending on whether we fail to reject or if we rejected. Now, in our case, we rejected HO, but let's take a look at what this conclusion would look like had we failed to reject. Whenever you fail to reject, you say, as the second part of the conclusion, you say there is insufficient evidence to conclude, and then you say whatever your alternative hypothesis was, your research hypothesis. Because there was insufficient evidence to prove what it is you were trying to prove. So let's take a look at what that would look like in our case had we failed to reject. We would have said, at an alpha level of 0.05, there is insufficient evidence to conclude that the average weight of infants born in our hospital is less than 3,100 grams. However, we didn't fail to reject. We rejected. So if we reject, we would say this. We would say at an alpha level of 0.05, the average weight of infants born in our hospital is significantly less than 3,100 grams. And we try to say the word significantly as snobbishly as possible, because we've really achieved something when we find something significant. That's what we're trying to do as researchers. So we would say at an alpha level of 0.05, the average weight of infants born in our hospital is significantly less than 3,100 grams. Now comes the third part. The third part I call the statistical string. And it changes depending on what type of statistic you did. But it almost always starts by telling what the statistic was. In our case, we did a t-test. And then it's followed by a parenthesis and usually followed by the degrees of freedom. So in this case it's T, parenthesis 9, because we had 9 degrees of freedom, and a parenthesis. Then you put a space, an equal sign, a space, and then we put what our T comp was. In this case it's negative 2.2678. Then we put a comma, and then we put a P. That P actually should be italicized. Then there's a space, an equal sign, a space, and then we put our P value that we got from Excel. Now, if we didn't get a P value from Excel, we would know that because we had rejected, that our P must be less than 0.05. If we failed to reject, then we'd know that our P was greater than our alpha, which in this case is 0.05. But because we have Excel, we could know exactly what it is, so we might as well put it. We put P equals 0.0248. Then in parentheses, we put whether this is a one-tailed or a two-tailed test. Now that's done with t-tests, and it's done with several other tests, but it's not done with all statistical tests, because some statistical tests can only be one-tailed. In this case, this is a one-tailed test. This one could be one or two-tailed, so we have to say that this is a one-tailed test. Now let's put this all together. Here are our 7 steps. Let's look at the 7th step first. At an alpha level of 0.05, the average weight of infants born in our hospital is significantly less than 3,100 grams. T with 9 degrees of freedom equaled negative 2.2678. Our P was 0.0248, and we did a one-tailed test. Now let's review all 7 steps. I start out by doing step 2. I state what our research hypothesis is. In this case, we believe that the mean is less than 3,100 grams. For the HO, step 1, we have to put everything else that's possible. In this case, we'd say the mean is greater than or equal to 3,100 grams. Now, if we can rule out or show that it's highly improbable that the mean is greater than or less or equal to 3,100 grams, then our research hypothesis must be true, or is more likely to be true. Then we say our alpha, step 3, is our probability that we're willing to be wrong, in this case 0.05. 4, we put a rejection rule. This is, at this probability, what would we have to get for t before we could decide to reject the null hypothesis? Step 5, we use Excel to find the t-comp. In this case, we got negative 2.2678. Step 6, because by our rejection rule we get to reject HO, we reject HO. 7, we write our conclusion. Now, the conclusion is the only thing we publish. The other 6 steps are just to help us get to our conclusion. But for this class, you do have to do all 7 steps. But when you write up a research study, all you'd say is at an alpha level of 0.05, the average weight of infants born in our hospital is significantly less than 3,100 grams. T parenthesis 9 equals negative 2.2678. P equals 0.0248, and it was a one-tailed test.